Now that we've covered the concepts, features, and structural elements in object-oriented Java, it's time to put the pieces together and take a look at a case study. Case study ex0 shows how abstraction, inheritance, and polymorphism work in the context of object-oriented Java. All the source code we'll be covering in this video is available in open source form at the link at the bottom of this slide. We're now in my IntelliJ project for case study ex0. As we mentioned earlier, this example shows how abstraction, inheritance, and polymorphism work in object-oriented Java. In particular, it defines a hierarchy of simple set classes that use the corresponding Java set collection classes in their implementations. We'll start by taking a look at the main entry point, which is the way the test program starts to run. As you can see here, the main method first calls makeSet, which is a factor method that makes the appropriate simple set subclass object. And it does this by passing in a string parameter that defaults to hashset, that you can override that by providing a command line argument instead. Let's take a look at the makeSet factor method. This method takes in the string type, does a switch on that type, and then handles the various cases. If hashset is the string, we'll make a new simple hashset. If treeset is the string, we'll make a new simple treeset. If concurrent hashset is the string, of course, we'll make a simple concurrent hashset. And if the set type string doesn't match any of those cases, then we throw the illegal argument exception. Let's go ahead and take a look at the implementation of these various classes to show how abstraction, inheritance, and polymorphism work in Java. We'll start by taking a look at simple hashset. As you can see, simple hashset extends simple abstract set, which itself implements the iterable interface, which provides various methods such as the Iterator method. We're going to go ahead and define three methods here in simple abstract set. We're going to define Iterator, which is an abstract method. We're going to define contains, which is also an abstract method. And we're going to define add. So these three methods, Iterator, contains, and add, correspond to the public application programming interface, or API, of the simple abstract set class. And by defining them as abstract, that provides an obligation for the subclass that extends this particular superclass to make those methods in their implementation in the subclass. So that's basically the superclass for all these things. Let's go back now over to what we were looking at before, which was simple hashset. So simple hashset defines a field, which is part of its data model. In fact, it is its data model. And that's going to be implemented by hashset. So the field is called mset. It's a set interface type, and we're going to implement it using the hashset. If you take a look here, you can see we then implement the iterator method by forwarding to mset iterator. We implement the contains method by forwarding to mset contains, and we implement the add method by forwarding to the mset add. So basically, we're implementing this particular simple hash set by forwarding to the hash set. And of course, this is also illustrating a number of other concepts. In addition to data abstraction and inheritance, we're also showing the use of dynamic binding or polymorphism, because these methods are going to be dynamically bound. I won't spend a whole lot of time on the other set subclasses. We have simple concurrent hash set, which is implemented using something called the concurrent hash map key set view class. And it, again, goes ahead and forwards all the methods. And the difference between hash set and concurrent hash set is that concurrent hash set will work properly in a multi-threaded program without having to worry about race conditions or corruption due to concurrent access from different threads. And then finally, simple tree set goes ahead and extends simple abstract set like the other two subclasses did. It makes a tree set as the set field, forwards the methods, as you can see here. Because tree set needs to be comparable, the values have to be comparable to be ordered, we have to make sure that the element E extends the comparable interface. So those are the different classes involved. Now let's go ahead and go back to the main method and see how those classes and instances of those classes are actually used. So makeSet returns the appropriate implementation class. And then if you go back over to where makeSet is called, you can see the next thing we do is we call test add, test contains, and test iterator. And this passes in the set. Notice I used the var keyword, which is a Java 11 feature that allows us to not have to write the concrete type. But our IDE here is nice, and it says this is actually a simple abstract set. So we're going to be making calls through a simple abstract set superclass reference, but in fact, the implementation is one of the subclasses: hash set, simple tree set, simple concurrent hash set. So let's take a look at the test add method, which just takes in a simple abstract set as the superclass. And you can see what it does is it says set add. It basically adds I am Iron Man, and make sure that those are all correct. They should return true in every one of those cases. And then we go ahead and try to add Iron Man again, and this time we assert that it returns false because you can't add duplicates to a set. So that's what test add does. And notice how all these calls are done through a reference to the superclass, even though it's actually calling the method on the subclass, in this case, the hash set. Let's take a look at test contains. More or less the same idea. We pass in the simple abstract set, and then these are all virtual method calls using polymorphism, and they're asserting that the set contains I am Iron Man. And also the set does not contain other strings like Thanos or Bill Ward, all of whom are associated with the phrase I am Iron Man in different ways. And then the final thing we're going to do is we're going to test the iterator. And this is kind of interesting because what we're going to do in this test iterator is actually use what's called a for each loop in Java. And the for each loop uses the iterator on this particular collection in order to be able to get something that can be iterated over with the for each loop syntax. So for each of the elements in the set, we're going to go ahead and print out the item. So if we compile and run the program, you'll see what we get. Because we've instrumented all the different classes, all the different subclasses to print out what the concrete type is, you can see that we have simple hash set add being called, and simple hash set contains being called, and simple hash set iterator being called, and then we print out I am Iron Man. So hopefully this illustrated how data abstraction works by being able to abstract the details of the implementation of the various subclasses like simple concurrent hash set, simple hash set, which abstracts away from the details of what's actually used as a field. It also illustrates the concept of inheritance, where we're inheriting from a base class, or a superclass in this case. And then we're also showing how the use of dynamic binding enables us to be able to go ahead and polymorphically invoke operations through superclass references that actually make method calls on the appropriate concrete subclass.